Hello everyone, we are going to share about our idea for the project, which is on the title of Polyionic liquids or ionic liquids mixed matrix membranes for carbon dioxide methane separation. For your information, mixed matrix membrane is the incorporation of solid phase in a continuous polymer matrix. It is considered as a new generation membrane for gas purification application. Ionic liquid is liquid that contains cation and anion, and it is green solvent. Polyionic liquid features species of ionic liquid in each monomer repeating unit and macromolecular structures if formed by connecting through polymeric backbone. The significant properties of ionic liquid are included into the chain of polymer, and it leads to formation of new category of polymeric materials. The issues identified firstly is the presence of carbon dioxide impurities in natural gas methane depresses the heating value, and carbonic acid will be formed in the presence of water that damage pipeline equipment. Next, the emission of carbon dioxide into the atmosphere from the burning of fossil fuel is also treated as one of the major factors for global warming.
Therefore, the objective of this project is to study the synthesis of butyl-methyl-imidazolium lysine with polyvinyl-benzyl trimethylammonium glycine mixed matrix membrane. Secondly, it is to study the application of polyionic liquid with ionic liquid mixed matrix membrane in carbon dioxide removal. In this project, mixed matrix membrane is fabricated by using polyionic liquid and ionic liquid. It is synthesized by using BMIM lysine and poly-VBTMA glycine. For polyionic liquid, it will be synthesized by using photopolymerization technique in the presence of 2-hydroxy-2-methylpropionol as photoinitiator and divinyl-benzene as crosslinker. Next, we move on to the procedure for preparation of polyionic liquid with ionic liquid mixed matrix membrane. Firstly, 2 grams of VBTMA glycine monomer was mixed with 0 and 5 weight % of BMIM lysine respectively and was stirred. Secondly, 63.7 micromilliliter of divinyl-benzene and 17.6 micromilliliter of 2-hydroxy-2-methylpropionol are added to the mixture via micropipette. The resulting mixture is mixed thoroughly by using orbital shaker for 5 minutes at 480 rpm. After that, nylon, which is a membrane filter, it is placed onto a rain-coated quartz plate. The resulting mixture is put onto the nylon and it was casted between the 2 quartz plates. Then, each side of the membrane surface was exposed for 30 minutes under a 365 nanometer of UV lamp at room temperature. The common applications of mixed matrix membrane are wastewater treatment, metal ions removal, gas separation, oil treatment, and so forth. For this project, it focuses on its application in CO2 CH4 separation. Gas separation using membrane, it is based on the absorption diffusion mechanism. The driving force for the separation of gases, it is a pressure gradient. Other than that, this project outcome is on the characterization techniques performed on the ionic liquids, polyionic liquid, and the mixed matrix membrane. Here shows the proton and amount of monomer VBTMA glycine. The synthesis of the monomer is considered successful based on the results shown, as peaks represent for the protons of the monomer structure are shown. Next, it is the FTIR results of the monomer, which is VBTMA glycine, and the mixed matrix membrane, which is poly-VBTMA glycine with 0 and 5 weight % of BMIM lysine respectively. By comparison of all these FTIR spectrums shown, the peak intensity of the functional group of poly-VBTMA glycine is higher than its monomer. This is probably due to the hydrogen bonding interaction in the functional groups during the photopolymerization process. In conclusion, in fabrication of a good mixed matrix membrane, properties such as permeability, selectivity, and mechanical strength will need to be satisfied and considered in this project. That's all for my sharing of idea for this project. Thank you and have a nice day.